Okay. Now the part where we are going to communicate with the shader and pass our triangle to the shader. We need to create this temporary memory or called buffer. So since we are in CS, I assume we know the term buffer very well from different algorithms and other stuff. Buffer is this temporary memory, right? Which is primarily used for some sort of temporary calculation or passing some value from one place to another. So we are going to use this vertex buffer here that we are going to use. So these are our vertex. This is our vertex array, right? So these are our vertices. We're going to use a buffer to bind this array to our vertex buffer. Then we're just going to send that buffer to this shader, this vertex shader. So let's keep working on that. So I'm going to create a vertex buffer. Then in the temporary memory, I'm first initializing the buffer. So this is GL create buffer is a function that, again, you can see GL. So this is standard function defined by WebGL, OpenGL, or GLSL. So then I'm going to see if it is successfully created, because there can be error with that. So if not vertex buffer, then I'm going to throw an error saying something like failed to create buffer, or initialize or create buffer is fine. And I'm going to quickly run this to make sure no error so far. No error so far. I don't know that if that is a good news or bad news, but yeah, we'll continue with that. Now we have a vertex buffer. We need to bind our triangle, right, to the vertex buffer. Okay, so how we are going to do that? First, we are going to define how we are going to bind the vertex buffer. So we are going to use this function called bind buffer. And then we're going to use array buffer. So there are different types of, there can be different types of buffer, but since our triangle is in this array, we're going to use an array buffer. Then we are going to say the name of our array buffer is going to be vertex buffer. Okay. So any questions so far? This part can be tricky, and reminding all these things can also be tricky, but with more practice and with running more example from the book, it will eventually be much easier for you. And how do you know all these functions, or especially the GL functions? So if you search for this function, I would say go with WebGL, and then because there is a different version called OpenGL that is C++ based, they have sometimes different ways of defining this function. So this is WebGL rendering context, right? And you can see that there is this developer doc that gives very well-defined description and with examples here with each of the functions. So every time we encounter a function that we're using, we can always do the documentation or read the documentation at that Mozilla documentation website. And in fact, our resources tab section here is also giving you examples from that same developer Mozilla org website. Okay, so we are good so far with the bind buffer. And then what we are going to do next? Okay, so we have this variable called a position, right? We need to connect with this variable, right? we know we are going to eventually send our data to the A position. So since we have our buffer ready, the next thing is we are going to create a similar variable here. Also going to call this A position. In the CPU side, this A position is in the GPU side. So we have a different A position, and that A position we're going to connect with our GPU side A position, right? So GL and another function that is called get read location. I hope there is no typo, because if there is, we're going to be in trouble. So read location, then GL, right? And we are going to use program. And then we are going to use A position. Just to make sure this is capital. So I'm going to copy the whole thing here. And then I'm going to tell the function that this is the name of the variable that I'm going to use. Okay. And then the next thing is I'm going to so this is the location of our attribute variable, right? So this was our attribute variable. We need to define how we are going to connect our attribute variable with this array. So I'm going to define that here. So I'm going to say GL vertex attribute. And this is also attribute pointer. So we're going to set a pointer to this variable A position, and then how many components do we have in each of our points, right? So initially we started with 2 components, X and Y, but then we thought we can also have the Z. Even though this is 2D, you can have it 3D, and then we can make this 0. So that's why we're going to use 3. So this our points are 3D, right? And then our points are GL float, and then we need some other components. So just to refresh my memory, I'm going to check the documentation. So GL, okay. So we need the index. The index is A position. Then we need the size of each of the component. Size is 3. The type defined as float. Then we need to normalize that or not. We're not going to normalize that because our value is already normalized. I assume the value is in between 0 to 1. So I'm going to make this false. Then you have this stride and this offset, right? So you learn more about this stride and offset. I'd recommend reading this. So we are going to set both of them as 0 because we don't have any additional data. So there was a possibility that we can have additional data here, right? For example, color. We could have other things like types of a bunch of things you can have there. Then you wanted to jump the, so if there was color, you didn't want to read the colors, right? So using this 3, we want to read each 3D value. Then if we had like RGB, then we want to jump 3 values, then go there and read the next value, right? For our case, we don't have any of this data here. Our data is only containing the locations. So both of our offset and stride is 0. In the book example, eventually we'll find examples that have very large arrays where they have color, they have normals, they have light, a lot of stuff packed together. So that was loosely packed. That will be loosely packed variable. for our case, we have a tightly packed variable, so we can go with 0 and 0. That's what they're also saying here. But I recommend reading this documentation. This is really good, and their explanations, I always understand everything very clearly there from the explanation, also from the examples. The examples are also very nice. Okay, so let's move on. We don't have a lot of time, so I'm going to pick up the speed, and at this point I'm going to enable the vertex attribute array. So that is another function, enable vertex attribute. And then array. Inside that, I'm just going to enable this variable. I'm making this our attribute variable, right? Okay, so once that is done, now we can connect this and this. In order to do that, I'm going to tell OpenGL where the location of the buffer data. So the buffer data is in the array called triangle, right? The buffer data, we're going to use array buffer. Similar to this. And then the name of our buffer data is triangle. And then we are going to do a static draw. That's why to mention static. So we can have dynamic and static draw. I am not going to talk about that because for whole 160, we're going to use the static draw. So we are good with that. So let me quickly refresh this and see what kind of error we have. Okay. So vertex attribute pointer, we need 6 arguments. We have only, that means something is missing here. So a position, GL4. Oh, I missed the false, right? We don't want to normalize that. So false. Okay, now we're good. There is no more error, so I feel much better. Okay, so at least we connected the two things here, right? And we have our buffer ready for the drawing part. So any question so far? I know this is a lot to take in, if especially if you are doing it for the first time, but with more practice, eventually it will make more sense.